Welcome to the whitchermath channel. Today we're going to talk about factoring and expanding linear expressions. This is a 7th grade standard, but of course the skills involved here span across all grade levels, really. Factoring and expanding is really just another way of saying we're going to break down and put back together expressions so you can see all the different ways they can be written. Like all 6 of these that I have shown. See, 1, 2, 3, 4, 5. All 5 of these that I have shown here are equivalent. They're all the same thing. So in this video we're going to learn how can that be. We have all these things, they look different, yet they're the same. So when we're creating equivalent expressions, there are really infinite possibilities. There are countless ways in which you can rewrite an expression. Let me show you what I mean. Do one simple example here. For example, we can have 4x plus 12. And if we factor a 2 out of that, don't worry, we'll get to how to factor here in a second. It looks like that, but it's the same thing. If we factor a 4 out, it looks like that. If we distribute the 4 and show the distribution, it looks like that. If I just have a bunch of seemingly random terms here, but they have not been combined yet, it might not be obvious right away that this one that I just wrote here is also equivalent. Or for example, 17 plus 6x, let's throw a negative 6 in there, a negative 2x, and a 1. You might not think that this is also 4x plus 12 by looking at it, but it is. So you can see I could go on and on here. We could have infinite, endless possibilities. So we need a way of being able to tell if they're equivalent or not. That's very useful. So step 1, you always need to know how to combine like terms. All that means is combine means put together. Like means same. And terms, think of that as things or stuff. So we're just going to put together the same things here. That's what combine like terms means. Let me zoom in just a skosh. Okay, you can ask Martha Stewart what a skosh is. I think that's a cooking term. Okay, so let's focus on factoring and expanding here. Combining like terms, for example, if I just take this 1 here, I put all the x's together, and I'm going to put all the numbers together. And then I'm going to simplify, like 5 minus 1 is 4 x's, and then 4 plus 3 is 7, plus 6 is 13, minus 1 is 12. So you can see how just by combining like terms, it's really the same as that first expression we had there. It's just hard to tell at first. It's like it's in disguise. Okay? So, we all like circles. After all, you're in some kind of math class right now. Circles come up, we love them, right? They never end, they never begin, all that great stuff. I'm going to use a circle here to show you kind of how we can work through these expressions and be able to break them down and build them back up. At the top of our circle, we can say it's been simplified or expanded. And then if we work around the circle, we can factor. If we take another step in the process here, we can distribute. And if we continue, we end up right back where we started. Okay? Let me take this example for you here. If I start with something like 6x plus 18, there are no parentheses there. And that's probably the best way to think of what is simplified or expanded form. What does that look like? There's no parentheses, and we only have one of each term. So I have one x term and one number term. Okay? It's easy to tell when you're simplified. Then, if I was going to factor that, that means I'm pulling a common factor out of both things. Like, for example, I could cut both of these in half. So 2 is a factor. 2 times 3x and 2 times 9 gets us there. We can factor this in a number of different ways. Right? But the key to keep in mind here, what's the same with all of these things, is that this is common to all terms. In this case, we only have 2 terms, so it's common to both terms. But whatever number is outside the parentheses tells you how many groups are in there. This is what's in the group, and the outside is how many groups. Okay, so we can factor expressions in many different ways, but the thing they all have in common is that the thing outside the parentheses is a common factor to all the terms in the original simplified expression. Okay, and that's key because if we take this a step farther here and say, okay, let's distribute, let's show the distribution. We have 2 times 3x and 2 times 9. Right, that 2, in this case, got distributed to both terms inside the parentheses. All terms inside the parentheses, okay? So in the next problem, 3 times 2x and 3 times 6. This shows that you understand distribution, and also, more importantly, it gives you yet another way to write an equivalent expression. And this one, of course, would be 6x and 6 plus 3, and 6 times 3. Okay, so this just shows the distribution. You can see with our original expression here, 6x plus 18, I now have 7 different ways of writing this. And that's not even all of them. I'm just keeping it simple for a video. And if you don't think this is simple, then whoo! Yeah, this gets even more complicated. But the basic ideas are going to ring true. Now, if I take this a step further and get rid of all the parentheses, right, I'm going to complete all operations. Which means eliminate the parentheses. I end up right back where I started. That's why I made a circle here, okay? Because 2 times 3x is 6x. 3 times 2x is 6x, right? When I complete the multiplication here, I end up right back where I started with a single simplified or expanded expression. Okay, so just with this one here, I've got 7 different ways of writing it. Okay, so that's pretty much it for this video. I'm going to make another one where we do some example test questions, practice problems, things you might see when you're taking those high stakes tests. But the main thing to keep in mind here is we can break it down, we can put it back together, and every step along the way is considered an equivalent expression. Okay? So that's all I got for you on this video. I hope that helps make sense and that you tune into the next one where we can practice some of these problems, and also I'll show you using some manipulatives. Ooh, this is exciting. Look at this. We're going to use some of these things to demonstrate the different ways of grouping, and maybe that'll make it easier to understand. So you might want to check that one out. Thanks for watching. Talk to you later.